Hello, and thank you for joining me in this webcast about driving innovation in electronic circuits design, research, and education. My name is Mahmoud Wahbi. I'm a product manager at National Instruments, and I'm happy to be joined today by Keith Peckham and Mark McComb from Microchip. Let me start by giving you a brief overview of National Instruments. NI has a strong track record of sustainable growth and profitability. We believe that the best way to serve our customers is to ensure a successful, stable company which our customers can rely on for products that will be of consistent quality over time and provide customer service for the decades that our products will be used in. This sustainable ethic is reflected in our growth, our breadth, and our diversity, and we also reflect it in our culture of being a consistently great place to work throughout our offices worldwide. To explain what our company does, I first have to address what our mission is. At NI, we believe we can contribute to the impact of great engineering and science, the work that you and your company do every day. Solving multiple, complex problems has been NI's dedication from the beginning. We believe that engineers and scientists are key to making the world a better place, and we enable them with tools that help them better understand our world. That's why NI is forever committed to equipping engineering and scientists with tools that accelerate productivity, innovation, and discovery. The NI mission to equip scientists and engineers with the tools to enhance productivity, innovation, and discovery starts with education. We are very devoted to enhancing education, and over 8,000 classrooms have adopted our platforms around the world, through our academic program in particular. We have over 200 LabVIEW academies in nearly 30 countries, over 100 textbooks in more than 25 languages standardized on the NI platform. Over 200,000 students use LabVIEW radio architecture for robotics, and over 35,000 companies use NI tools to solve engineering grand challenges. So by bringing real-world experiences to education and combining theory with hands-on experimentation, NI gives students the opportunity to experience the theory they are learning and to really do engineering. Using the hardware and software they will utilize in their careers and research, students gain relevant experiences with applications that matter to them. Applications in controls and mechatronics, RF and communication, measurements and instrumentation, as well as circuits and electronics. In today's presentation, I will be focusing on our circuits education platform and its extension to different research and industrial design applications. First, the NI Multisim circuit simulation environment, which is the cornerstone of the NI circuits teaching solution, and it reinforces electronics fundamentals while preparing students for the laboratory. The pedagogical features of Multisim are built into an intuitive interface powered by industry standard SPICE simulation. Combined with Multisim and designed specifically for education, the NI Educational Laboratory Virtual Instrumentation Suite, or NI ELVIS, has the flexibility to engage students in comprehensive experiments with 12 common lab instruments, including an oscilloscope, a function generator, and a body plotter analyzer. In addition, the NI MyDAC is designed to expose students to a hands-on learning and project development experience anywhere at any time. The compact and portable NI MyDAC integrates 8 common lab instruments into one student-ready device. So when you look at the NI Circuits teaching solution, you realize it is a combination of ready-to-use courseware content, simulation software that is geared towards learning, and flexible hardware for hands-on exploration and student design. This complete solution significantly improves the learning experience for the student and effectively walks them from the electronic theory and fundamentals they learn in the textbook to the classroom and finally to the laboratory. At the University of Manchester, they were able to increase the student satisfaction of their courses by 31% in a single year and go from near the bottom of the national ranking tables to the top of the list. And in 2012 and in 2013, they maintained that position, all due to inspired and motivated educators and the addition of the NI tools to provide hands-on and practical work experience. But the story does not end here. It actually just started. On top of the great student design and research projects, over 35,000 companies around the world leverage our technology to solve today's engineering grand challenges. Through our hardware and graphical software integration, we accelerate the productivity, innovation, and discovery of engineers and scientists all over the world. So let's now take a look on how Multisim is actually being used by professional circuit designers for different design applications across multiple industries. In different industries, designers go through multiple stages in their circuit design process, from simulation to PCB prototyping, all the way to deployment and testing to verify their design performance and to learn more about its characteristics. Going through all of these stages to getting a final prototype working is called a design iteration. A designer's ultimate goal is to minimize the number of design iterations before getting to a production-ready design and handing it over to manufacturing. At NI, we provide the circuit designers with the complete solution that allows them to reach this goal. We work very closely with semiconductor manufacturers such as Microchip to provide accurate models of their hardware chips. Then we integrate these components in an intuitive graphical environment of Multisim where advanced analysis and virtual measurements could be completed. Then from within the same environment of Multisim, designers could transfer their simulated circuits to a PCB layout tool to prototype it. And finally, with the unique integration with NI LabVIEW, Multisim is the only SPICE simulator capable of performing complete system designs, including analog circuitry and digital control, as well as integrating real-world data and comparing simulation and measurements with test hardware integration. With this complete solution, we are enabling our customers to successfully create designs that range from low-voltage, high-precision applications to high-power electronics and many other circuits. Multisim is a well-established tool in multiple industries from aerospace and defense to life science to renewable energy and automotive electronics as well. And simply by going to ni.com/multisim, you can learn about our customer success stories from all of these different industries. With that, I would like to hand over to my colleague Keith Peckham, who will be giving you an overview about Microchip's company profile, academic program, and circuits application.
Hello, my name is Keith Peckham, and I am the Channel Marketing Manager for the Analog and Interface Products Division here at Microchip Technology. Today I will start with a brief introduction of Microchip and our academic program, then dive a little deeper into our analog product offering, followed by focusing on our latest operational amplifier product, the MCP 642X family. For high-volume, embedded control applications, Microchip is a leading supplier of high-performance, field-programmable RISC microcontrollers and digital signal controllers, mixed signal, analog and interface products, wireless and RF products, non-volatile double EEPROM and flash memory products, and flash-based IP solutions. Microchip is on an approximate $1.9 billion run rate for this fiscal year and globally has more than 8,000 employees, and Microchip's headquarters are in Chandler, Arizona. As mentioned on the previous slide, Microchip's annual net sales are on a run rate of approximately $1.9 billion. Microchip has performed very well with the last 93 consecutive quarters of profitability. As many of you well know, Microchip is known for its broad microcontroller product portfolio. From our beginnings many years ago in the low end of 8-bit microcontrollers, we have grown our product portfolio into a powerful platform of almost 600 MCUs. Complementing our leadership position in 8-bit MCUs, we have now built a strong portfolio of 16-bit MCUs and are on our way to doing the same thing with 32-bit MCUs. What's unique about the PIC MCU platform is that we offer our customers a compelling reason to adopt and stay with our platform because of the easy migration we offer within our platform of products, as well as by offering our customers the only unified development tools environment in the industry. The PIC MCU platform enables our customers to make a safe choice that preserves their R&D investment and enables their time to market. In addition to our microcontrollers, Microchip's analog product portfolio has also grown rapidly, continuing new product releases in the areas of power management, linear, and interface, just to name a few. Our analog portfolio has now grown to over 1,100 products. As you can see from the block diagram, our analog, interface, and memory products enable Microchip to provide a complete system solution. With an expanding portfolio of leadership products, industry-leading development tools, best-in-class lead times combined with consistent delivery performance, quality leadership with relentless quest for perfection, competitive pricing, outstanding support through all phases of a project, and consistent profitability and rock-solid financial strength combined all make up the Microchip advantage. In addition to our product portfolio, Microchip focuses on corporate responsibility. Giving back to our communities is an integral part of our culture. Microchip gives back to communities via company charity drives, employee contributions to the United Way, matching qualified employee donations, the Microchip Academic Program, and sponsorship of FIRST organizations and associations with various other organizations. Now I want to highlight the Microchip Academic Program. The academic program demonstrates our ongoing commitment to education by offering unique benefits and resources for educators, researchers, and students worldwide. Microchip partners with academia to increase the knowledge base in embedded applications and promote that knowledge with future engineers and innovations. Microchip offers access to labs, curriculum, and course material, silicon donations to help seed labs, and assistance in finding low-cost tools. Offers a 25% academic discount when ordering tools through www.microchipdirect.com. Microchip offers the following to our academic partners: free training at any of our worldwide regional training centers, RTC, for our academic partners. Regional Training Center course materials are available for academic use. The new academic portal for collaboration between academic partners, and we're just an email away to help point you to existing online resources and documentation. Email us at academic@microchip.com. So again, just email us at academic@microchip.com or visit us online at www.microchip.com/academic. Back in the introduction slides, I mentioned that Microchip's analog, interface, and memory product families complement our famous microcontrollers, enabling Microchip to offer complete solutions for our customers. So next, I want to present a brief introduction to our analog and interface products. This slide from Microchip's analog and interface products presentation, also known as TreeLink, illustrates our complete analog and interface portfolio. You can see that Microchip has an inclusive portfolio, including thermal management, linear, motor drivers, power management products, mixed signal, interface, and safety and security. Today we will focus on linear CMOS operational amplifiers. When you select single supply CMOS op amps, you are linked to our entire operational amplifier family, where you can further narrow down your search for a specific op amp product. So let's do that. When we selected single supply CMOS op amps in the previous slide, we were linked to our op amp family slide. This slide illustrates Microchip's entire operational amplifier portfolio. This slide is organized by gain bandwidth product and architecture, either precision or general purpose. Microchip's amplifiers cover a wide range of gain bandwidth product, from 10 kHz to 60 MHz, offering an easy migration path for our customers. We have general purpose amplifiers and high precision amplifiers, be it EEPROM trimmed, zero drift, or MCAL architecture. Today we will focus specifically on a new family of op-amps from Microchip, the MCP 642X family of single, dual, and quad general purpose operational amplifiers. So let's go ahead into detail on the MCP 642X family of operational amplifiers. So why use the MCP 642X operational amplifiers, and what problems can it solve? It can help with lower power savings due to low quiescent current, and that helps extend battery life. The MCP 642X has low leakage current, which helps keep the input error voltage low. This is extremely important in sensors with high output impedance and end applications that go through accelerated life tests at high temperature. The device also offers enhanced EMI rejection, which reduces input offset voltage error due to EMI signals at the input. So what are some of the end applications that can benefit from the features of the MCP 642X family of operational amplifier? Well, sensor amplifier and filtering applications, handheld gas detection and monitoring systems, low power medical devices, battery powered systems, and automotive. Gas detection and automotive are some examples of end applications in markets that use accelerated life testing for qualification. All of these applications can benefit from an op-amp that has low quiescent current and low leakage current and the EMI rejection. Let's review some of the key features. The MCP 642X family of general purpose operational amplifiers offer excellent DC characteristics. To name a few, 1 millivolt offset voltage max, low offset without paying precision amplifier premiums, high power supply rejection ratio 90 dB typical, low bias currents 1 picoamp typical, high common mode rejection 90 dB typical, and a wide supply range, operates down to 1.8 volts, and addition of the special feature, the EMIRR, EMI rejection ratio of 97 dB at 1.8 gigahertz. These key features make the MCP 642X an excellent choice when high performance is needed from a general purpose amplifier. For space-constrained applications, the MCP 6421 single amplifier is available in very small packaging, the SOT23 and the SC70. Let's review the features, benefits, and results of using the MCP 642X operational amplifier in a design. The features of low supply current, low leakage current, and low voltage operation provide the benefit of low operating current designs, low power consumption, resulting in batteries lasting longer. The feature of small packages, SC70 and SOT23, provide the benefit that the device occupies very little board space, which results in smaller overall designs. The features of rail-to-rail input and output and unity gain stability provide the benefit of the device being stable over a very wide dynamic range, which produces the result of making the device easier to use and ideal for portable applications. Let's review an application example. A photodiode configured in the photovoltaic mode has zero voltage potential placed across it. In this mode, the light sensitivity and linearity is maximized, making it best suited for precision applications. The key amplifier specifications for this application are low input bias current, wide common mode input voltage range, including ground, and rail-to-rail output. The MCP 64XX op-amps can be used to easily convert the signal from a sensor that produces an output current, such as a photodiode, into a voltage, a transimpedance amplifier. This is implemented with a single resistor in the feedback loop of the amplifier as shown. The optional capacitor, C, sometimes provides stability for these circuits. For evaluation purposes, the MCP 6421 has an evaluation board available with the proper BNC and SMA connectors for testing the EMIRR of the device. For analysis, a SPICE model is available, which can be downloaded free of charge from our website. So speaking of analysis, I am now going to turn over the presentation to my colleague, Mahmoud Wabi of National Instruments, to demonstrate a SPICE analysis of the MCP 6421 using National Instruments Multisim simulation environment.
Thank you, Keith. As you've seen, NI and Microchip have great offerings for circuit designers across multiple disciplines, from engineering education all the way to advanced analog and microcontroller circuit applications used in industry, with a simulation tool such as Multisim, and with great products offered by Microchip. In addition, NI and Microchip work closely on integrating the accurate simulation models of their components into Multisim. As shown on the screen, from within the Multisim database, you can search different component families and sort them by functionality. For example, the op-amp library shown includes many component models from Microchip, where the SPICE model could be viewed. The footprint information is available, as well as a brief description of the component, such as the quad 60 microamp high precision op-amp selected in the screen. So the Multisim database overall includes a variety of other models from Microchip that could be used for design purposes, such as a large library of operational amplifiers and comparators, accurate models of MOSFET drivers, mixed mode simulation of microcontrollers along with the analog front end, similar to the example Keith was talking about, as well as a large library of high pin digital component footprints. In this example circuit that I built in Multisim, I replicated the same transimpedance amplifier circuit Keith was demonstrating. Using a variable DC source, I am modeling the light intensity incident on the photodiode, and with the amplifier configuration shown, I am converting its current output to a voltage with specific filter configuration between the input and the output. The simulation helped validate all the right component values and the operation of the circuit without having to rely on a trial and error approach. As you can see, the output voltage given is shown on the probe number 1 at the output of the circuit. Here is another example where I built a circuit for an op-amp active rectifier using the MCP op-amp family from Microchip as well, and using the oscilloscope instrument placed directly on the schematic. I was a second away from reviewing my results in the transient time. This comes in addition to many advanced analyses that could be performed on a circuit like this inside Multisim, such as a frequency domain analysis, AC analysis, Fourier transform, as well as many sweep analyses such as the parameter sweep, temperature sweep, and the Monte Carlo and worst case analyses for optimizing the design performance before investing money into a PCB prototype and saving many prototype iterations. This is the real value of this huge effort we put together as NI in the simulation tool and as Microchip in modeling their components for the circuit designers. Before the end of the presentation, I would like to point you out to some getting started material. So if you are just starting to use Multisim, I would like to invite you to visit ni.com/multisim, and on the website you'll find all the getting started tutorials and training videos that will help you using the tool and ramp up the knowledge needed to start your circuit design. I would also like to point out that the Multisim offering includes a complete year of phone and email standard renowned NI support. This is in addition to free access to self-paced online training courses. So if you are thinking of using NI Multisim, you should not worry at all about how you are going to learn the tool and get familiar with it. We've got that covered for you, and you should be ready to go right away. I would also like to point out that Multisim, you can get a free 30-day evaluation of the tool by downloading it at ni.com/multisim/try. So I would like to invite you to visit this website and get your own version of Multisim today. And also I would like to invite you to join the NI circuit design community, where you can get updates on new tutorials and reference designs inside Multisim. You can get some shared designs and component libraries with Multisim users, and you can engage with the NI circuit design technical experts to get some recommendations and advices on your circuit design. Thank you for joining us today, and I'm looking forward to your feedback.